Thank you. I'm glad to be here, glad to be able to make this presentation. As we move forward, I want to go back a little bit just in time before we talk about the future of elevators. Let's talk a little bit about where elevators started, where they came from, what's happened over a career or a lifetime with elevators. Back in 1854, just a couple of years ago, was when the safeties were first developed for elevators, which really allowed passenger usage for elevators at that time. Up until then, people weren't riding with it on elevators. But since that time, we had a lot of different things that came into play. We had operators on elevators. We went from having just operators on elevators to where they were automatic elevators. Elevators went from AC, which had very poor leveling, to DC motors with motor generator sets, which were basically environmental nightmares. A lot of energy consumption, a lot of dust and so forth associated with that. Went from generators to where we had solid state power converters all the way to today we use regenerative drives to put clean power back into the building for whenever it's regenerated. We've gone from the DC motors to AC motors, and now we're using permanent magnet machines, again, for energy efficiency.
What does that mean, permanent magnet machine?
We've gone from an AC induction machine from the field coils to where we're using now permanent magnets instead of windings on the motors. So it's just a much more efficient motor. It enables us to also go to some smaller motors, machine roomless technology and so forth with that. We went from old relay panels to new microprocessor panels. Microprocessor panels now have more reliable technology associated with that. That technology has enabled us to look at two-button systems and to be able to dispatch elevators more efficiently, be able to move people more efficiently, and also to go on even to today where we're using destination-based controls. So we're no longer looking at how fast can we answer a hall call, how quickly can we get an elevator there to get people off the main entry, but we're more interested in how do we get them to their final destination the most efficient manner. The reliable electronics is also allowing us to take the destination calls and allowing us to go to programmable touchscreens, allowing the building owners to be able to do the programming themselves, a lot more customer interface with and customer change for those interfaces. And also allowing us to integrate more with security or other special features within the buildings themselves. Being able to go and interface that a lot of the systems themselves can now actually report when they're going to have faults. So we can do more preemptive maintenance on the elevator systems themselves. So all of this is going to become much more efficient, much more uptime for elevators themselves. But at the end of the day, over the last 100 years or better, elevators are still basically elevators. And we have one basic problem, and that is that as building heights increase, so do the number of elevators. Number of elevators that are required takes up more space. So being in the real estate business, one thing that's most valuable to you is usable space. So how do we start getting back more usable space, put it back into the buildings? Well, the only way we're going to really do this is going to be going to some type of multiple car type systems. When I say multiple car, I'm talking about multiple cars within one hoistway, more than one. With that, years ago, there was a product that was called a pedanoster. Pedanosters were a series of cabins where one car would go up, the other car would go down. They were in a loop. Didn't have doors on them. So back in the 70s, these were outlawed simply because of safety issues, but they were very efficient as far as moving people within a building. But the other thing everyone's probably most familiar with that has been around for a number of years has been double-deck elevators. with double-deck elevators, we're able to move theoretically twice as many people during your peak time frames, move twice as many people up into the building. Problems with the double-deck elevators is the fact that because the decks are set, building heights are set, floor heights are set, and there's also a huge mass that's moved at all times. So with a huge mass, we have big motors, a lot of power consumption, less flexibility during your off-peak hours. You're still moving that same mass. But also there was an irritation there for the passengers because there was always one deck loading and unloading, and the other deck is not there. The doors are stayed closed. So where are we today? Today we have the ability to take two banks of elevators, a high-rise and low-rise bank, what if we could take those and we were to combine them into one bank of elevators? We would take the cars themselves that would normally run side by side and let them operate one above the other. So it'd be like a double deck, but we allow them to operate independently of each other. On the construction side, it would certainly save a lot of different trades, save with construction of the buildings. But this also gives us the ability to go in existing buildings where populations have increased, where the elevator system itself isn't quite handling the traffic. We could actually add more elevator capacity to an existing bank. So with that,
I'm not clear what you're suggesting here.
this is all talking about from construction.
Yeah.
If we can take your high-rise and low-rise bank of elevators, combine them and make it just one bank of cars, where I have two elevators, one operating one above the other in the same shaft, I can now eliminate the cost associated with building the other bank of elevators, right? The bank of shafts. That space also now becomes net usable space for you.
Sure. But so going back to the stacked elevators, and you just described the disadvantages of it.
It would be very similar to that. But the advantage here is that they would operate independently of each other. Whereas here, both decks are fixed. They operate together.
Right.
I'm going to say let's unbolt them, allow them to operate independently of each other.
But the higher one can't pass the lower one.
Correct.
Okay.
So, but that'll add efficiency still to the system. I'll get to it in just a minute. So with that, we have a product we call Twin. Twin was something that the idea for Twin is not something that's new. There were actually patents issued back in 1907, 1931. And 1931, there was a Twin system operating in a manufacturing facility in Pittsburgh. What we have for Twin is we have two elevators that would operate independently of each other, one above the other. They each have their own machine, each have their own controller, own counterweights. All they do is they share entrances and they share the rails. But other than that, two cars actually operate totally independent. With this, unlike double deck, when you have a double deck system, every elevator within that bank is double decks. But with the Twin system, we would typically have a single car within the bank itself. So one of the shafts would have a single car, the rest of them could have the Twins. And we're always going to use the destination-based controls. Safety, how do we keep the cars from running into each other? There's a 4-level safety system that continually monitors the speed and position of both cars. With this system, we use some special electronic systems with the highest safety ratings of those systems, SIL level 3. With those systems, this is something that's used in the aircraft industry for fly-by-wire, used in power plants. This is a SIL 3 devices are the highest safety level that's there. The kind of a comparison to that is, because I know that sometimes the SIL level doesn't mean a whole lot to us, but if we look at the automobile industry today, they're using SIL level devices there for all of your speed controls and your blind spot indicators and so forth, but those are all SIL 2 level devices. This takes it one step further. With the SIL 3, we actually have different sensors, 3 different sensors within the shaft, that they always compare the speed and position of the elevator at all times to make sure that it's safe for the elevator to keep running. With that, anytime that we had to activate any one of the safety systems, the elevators will always stop, and the system is designed so that the cars will never touch. First twin systems, modern day twin systems, were installed back in 2002, and since that time, no safety level 3 or 4, no emergency safety level stops have been activated. Yes.
How do you handle the air pressure when you've got 2 cars in the same shaft that both take up pretty much the entire shaft, and they're coming towards each other? Aren't you going to create a very high pressure inside that shaft as those 2 cars are moving?
No, there's still enough space between the 2 cars that air pressure doesn't come into play. It's not a factor. And you also have, because the way the cars are roped, you have cables that come down the side of the cars, so there's actually a little more space on the side of the cars to allow for some airflow as well. Yes?
For accessing the elevators to get into them to start, are you accessing from 2 different levels, or is the lower cab going below grade while the upper cab loads?
You can have a couple of different ways. You can have the 2 lobbies the same as you would for double deck, an upper and lower lobby,
Right.
which is the most efficient way for loading and unloading the cars. Or if you have a cellar or below grade space, you can push the bottom car below grade and allow the top car to come down to the main entry level, have only one entry level at that point. Once that top car clears the zone, then the bottom car would come up and answer the calls there.
What efficiency issues do you have, given the fact that to run the lower car, you've got to run the upper car, even if there's no call for the upper car?
Not necessarily. Because we're going to use destination-based controls, we're going to assign the call to a car that's the most efficient to get a person to their destination.
Got it, right.
Potentially, you may have to move the upper car out of a zone for the bottom car to answer a call there, but we're going to actually increase the size of the banks of elevators. Typically, we would have maybe a 4-car bank, but if we put the twin units in here, now we've gone to 6 or 8 car group of elevators. So we have more cars to assign calls to, and we can allocate the calls to a car that's going to get there most efficiently.
Does this extrapolate to triplets?
Potentially. I'll get to that
Sorry.
soon, yes. I mean, that's something that is coming in the future, is even more cars, right. Right now what you have is multiple banks of lifts, and so someone is coming in that goes to the low-rise portion of the building, there's still those people in the low-rise portion that are leaving, right? Or someone comes in and goes into the high-rise portion. So you're still going to have that same transfer. And you can have, it is possible to do a zone operation where the upper car would serve the upper half of the shaft, the bottom car serves only the lower half of the shaft, or you can allow both cars to serve virtually every floor of the building. And it depends on the type of building that we have as to how the application would be applied. So for residential, for instance, you would have both elevators that would serve virtually every floor of the building, so that potentially the bottom car would pick up a passenger at the top part of the building and take them all the way out.
A lot of learning in this system.
There's a lot of learning in this system, but there's we find it to be not much different. Double deck there was a lot of learning with those to begin with. People come in with the upper and lower lobby. You have odd and even floors to be served. But this is still keeping it where you have, with the high rise and low rise, you still have those same floors that are served by only one elevator. It's a matter of which lift or which floor. If we have dual lobbies, which lobby would someone have to start, enter and exit from? And all this would be taken care of through signage, building signage, and so forth.
What's the difference in cost between traditional, single, and the twin?
And the twin, it'll be slightly more than double, because you're going to have, you'll have two elevators itself within that shaft. So it's probably 2.1, 2.2.
Sorry, the cost for the twin versus a single is 2.1?
About 2.1, 2.2
Why would,
times the cost of a single. You're going to have, it's actually two elevators. So instead of the two elevators being side by side, which would be the cost of two cars,
right,
now you're going to still have two, but they're going to be one in the same shaft itself.
but it's 2.1 the cost of the cab, not the whole, not the rails and all the mechanisms?
All the entire system, yes.
Okay. Sounds odd to me, okay.
But the only thing that you're not going to double on is the rails. The rails for the car. Because if I had a high-rise and low-rise bank,
Right.
I have low-rise through 10, and then I still have the entrances for the upper part and the entrances for the bottom part.
Right.
And I still had the rails and all the other electrical components and so forth as well. I have all the machines for both of them, for both cars. And I still have a high-rise and low-rise bank, but it's just in the same shaft.
Okay. Is there more in your?
I've got some more, yeah. So one of the biggest problems we have with this system is that of code compliance and code acceptance. The elevator code does have a performance-based section in the code now, but not all jurisdictions across the country have accepted the performance-based code. We do have our certificate for compliance for that code. This is also a certificate for compliance for the European code. So it's important that we get the local jurisdictions to also have some avenue to be able to accept some type of new technologies. And we approach the various jurisdictions as we have projects in those particular areas. We've been quite successful with getting approval across the country. We are looking at, here in New York, trying to get approval here. References globally, there's over 260 units now that have been installed. This map doesn't show anything here in the U.S. It was mostly because there was code-related issues. The codes are different here in the U.S. than they are in the other areas. But we do have, there is a project in the U.S. that's now under contract and being installed, so there will be products here in the U.S. So this is where we are today with multi-car systems. The dual car system is here, the twin is here. Where are we going in the future? The future is going to have what we're going to call multi, which is going to allow for multiple elevators, more than two, to operate within the same shaft. We're going to have, with the multi-system, what we've looked at is we've looked at linear motors and some high-speed train, maglev technology. So instead of trains going sideways, or going horizontally, why can't they go vertically? We're taking that, combining it with the safety technology that we have out of the twin system, and we're going to create that paternoster group of cars that circulates within the building itself. And so with that, we're going to have the multi-system, and multi will enable cars not only to go vertically, but will also be able to go horizontally. So this is what the future is. Elevators, no ropes, eliminating all the cables for the elevators.
So the motors are in the cabs themselves?
The motors are in the cabs themselves, right. We also have a mock-up, third scale mock-up that is in operation today. So we know that by concept, we know that it works.
Where is the mock?
Yes, in Spain.
Would you mind saying a bit about how removing ropes will affect the height possible for a skyscraper?
Sure. By doing this and by removing the ropes, the one thing that we have is elevators as we know them today, there is a mechanical limitation to the overall height that we can go. So when we get to be certain heights, the size of the machine, we're dealing with the mass that we're trying to move, the cables, the weight of all the cables and all creates bigger machines, and so at some point in time there becomes a physical limitation to the overall height that we can go. By eliminating the cables and going to this maglev type technology and linear motor technology removes that limitation for any building height from a design standpoint. So everyone's talked about the kilometer tall building and so forth. So this is most buildings today, they have sky lobbies because after buildings get to be a certain height, we have the transfer floors. But we also run into, the taller the buildings, we run into a lot of building sway issues with elevators. Shafts have to be oversized and to accommodate the building sway. With this, there's a lot of those issues go away when we start going to the linear motors.
Why does the sway issue go away?
There will be some sway issue, but each of these will come in different sections. So the sections will have some capability of moving with the building.
So that was my question for the drawing, the visual on the left.
Uh-huh.
Why are those, are you intended to take the first one, are you going up 4 different cabs to get to the top of that building?
Not necessarily. And this was just an animation that we put together to show that the cars will be able to go vertically and they'll also be able to go horizontally. Now, what is that going to totally look like when the product is introduced? We don't know. I mean, the initial introduction will be cars used as shuttle cars, mostly to sky lobbies or to observation decks or something along those lines. And then for the local cars, once you get to the sky lobby, the local cars could be machine roomless cars or they could be the twin car. To where we can continue to reduce the amount of space that the elevator shafts take up. The twin system itself will reduce the amount of space in the core by up to 30%. The shaft sizes themselves are slightly bigger than conventional shaft sizes, but because we're going to eliminate shafts by stacking the elevators within the same shaft, we're going to eliminate the other bank of cars. So it will change roughly 30% savings in the overall core. When we look at new buildings or new construction, we look at both the speed and it's all based on the size of the building itself and whatever the requirements are, whatever the population is. And we'll run studies, or the consultants will run studies to determine what the speed of the elevator is that's required in order to properly service the building. And with that, they determine the number of cars as well. We're beginning to see that in the planning stages, okay? And what happens is typically because we're planning for denser buildings, the one thing that happens is you have more elevators, you have more people, and typically whenever there's more people within the building, it translates into needing more elevators. So, again, it keeps compounding itself. You have more elevators, there's more core space that's taken up. So that's where the twin system or these multi-car systems help to reduce the number of shafts that are required.
Is there any time expectation as to when you would envision this continuous loop of elevators being installed somewhere?
This multi-car system right now, we'll have a full-scale model installed in our test tower at the end of this year. And at that time, we'll start the certification process for all the code requirements on it. We're thinking probably 2019 roughly, before it's totally certified. But there.
And I'm assuming that you can add or subtract the number of cabs in the loop for different times of day based on demand.
Yes, you'll be able to do that. You'll be able to take cabs out of the loop in order to do the maintenance.
Sure.
And the one thing we'll have, the number of shafts that are going to be required as well, simply because you can put more cars in the shaft. So the number of shafts are going to be greatly reduced. And this will allow for, the cars themselves are going to be much smaller than what regular elevators are today, traditional elevators are today. But what the theory is behind it is that you have cars that you can put 7 or 8 people on, but every 20 seconds, you've got another car that's there to be able to pick people up. So the queuing in the lobbies today, there's not large queues in the lobbies, and so we'll be able to move the people. As long as we can keep enough cars coming, we can clear the lobby out, which is the main goal for all the elevator systems today. Yes. Yes.
Could you bring me up to speed on what the current technology is for your mock-up? What kind of motors and traction device?
Yeah, this is, they're using the linear motors, and we've got these are all the motor windings are all here, and then on the car itself, there's a permanent magnet motor that's mounted on the car. So, and it uses a maglev type technology, and there's a rail that's there for guiding the car, and safety's on the car, brakes on the car itself.
And the permanent magnets attached to the cab?
Yes.
And the power is flowing through?
Power is flowing through these tracks here. Those tracks are energized and to enable the cars to move.
Like a subway.
So it's like a subway train. Yeah.
That picks up the power. The spinning motor is in the cab?
Is in the cab.
And what type of motor is it?
It's a permanent magnet motor.
How did you solve for the right angle? Subway cars here have to make these long sweeping turns to stay energized.
What this has, you can't see it very well here, but this section, top section right here, will turn 90 degrees. So when the car will come up and it'll stop, and that section on the back will then turn 90 degrees and it'll allow that car to move horizontally.
Traction is 90 degrees without altering the cab.
Right.
How the hell to do that?
It's all built in. It's on the back of the cab and so forth. So that track and the motor and everything will turn 90 degrees. And then when it gets over to the other track, it'll turn back again the other way.
So on the what exactly is the mock-up always going to be?
I'm sorry?
Your mock-up, where is it?
It's in Gijón, Spain.
In Spain.
Right.
hardly even tested any if they go sideways on this turn to make that right angle. Is there any
That,
effects on passengers?
well, that's a really good question, and that's one of the issues that we certainly have to, as we go through the testing process and procedures, writing our risk analysis and so forth for that, that's one of the things we have to take into consideration. Where we are right now is the cars will be introduced mostly for shuttle cars right now to get to sky lobbies, and so the passengers will only be going in the vertical, and then they'll get off, and then it will transfer to the other shaft without any passengers on it. And the big question is, how do we accommodate that for passengers when they're accustomed to going vertically, and then now you're going to all of a sudden change and go horizontally? How do we deal with it? That's still one of the issues that we have to resolve. Any other questions?